Guys, welcome back. Today's topic is field due to different shaped bodies. That means disc, arc, ring, conducting sheet. That means conducting cell or non-conducting solid sphere, conducting solid sphere. About this, the maximum I will try to explain today. And if you know the field, how to calculate, so you can make easy by using the Gauss law. That is another topic I will explain another day. So now if you see field due to uniform charge ring. So already I have given the field due to conductor, uniformly charged conductor, finite length, infinite length, and semi length, one side of the conductor. How to calculate I have given. So here is the topic is due to the charge ring. So see here, considering of charge is Q. The charge distribution on the ring is Q. Total charge is Q. Total charge distribution on the ring is Q. So consider a small element, that is dq. dq is small element, which is equal to, if the ring is plane, so that equal to, I can go with lambda into linear charge density for ring, lambda into dr. So that equal to lambda into r dt for ring. So d to this dq charge from the ring in the x distance from the center of the ring at the point P, I want to going to find out the field d to this dq charge. From this point, from this dq, it is in the distance root over r square plus x square. So here r is the radius and x is the distance from center to the point P where I want to find out electric field. So as previous discussion, the field is line joining these 2 points. Here at the point P, there is a unit charge is there. On this charge, by dq element, how much field means, that is dE. So dE is equal to, dE is the electric field due to electric field, magnet of electric field due to dq element or small charge dq on unit charge at point P. So that will be k into dq by root over r square plus x whole square. That means r square plus x square. So if you see, consider this plane is symmetrical charge. In symmetry point for this dq is also there here. Due to the symmetric charge, the field at P is like this. This is also dE due to this small element, again symmetric distribution of charge. So now the dE has components y and x, and y and x components. So this y components due to symmetric charge will be cancelled. Only dE cos theta component will be integrated. Therefore, the E is equal to electric field due to total charge Q is equal to integral dE cos theta. Integral dE cos theta. So that is equal to integral k into the dq, I can write lambda r into dr, lambda r into d theta, or dq keep like that. So the dq integrated means we'll get q charge. So then dq I can integrate. No need to write lambda r into theta. Cos theta value I can substitute from this. So r into d theta. However, you can do, no problem. But for simple case, I'll go with dq only. So dq into cos theta value from this adjacent side by hypotenuse, that equal to x by. So here already r square plus x square is there, and so here r square plus x square whole power 1 by 2. So that is equal to k x by r square plus x square whole power 3 by 2 integral d. So that is equal to, the field is equal to kqx by r square plus x square whole power 3 by 2. So this is the field due to ring. So field due to ring. So this field, when it will be maximum? So field is maximum. The maximum field can be said, the field due to this ring, it depends on the distance x from the center or point at where. So therefore, dE by dx is equal to 0 at what value of x, then the field said to be maximum. To find out the maximum value of field, this is varying with respect to x. So dE by dx make it 0, you will get maximum field value. So here is there x in numerator, denominator also x is there. So therefore, u by v method you apply, then you will get, after u by v applying dE by dx, you will get x equal to plus or minus r by root 2. So where x is equal to plus or minus r by root 2, field is maximum. So u by v method you have to apply this one in derivation. So you will get r by v. The graph will be like this to the distance and the field. So at x equal to 0, the field is minimum, and at x equal to, this is minus r by root 2 value, and this is plus r by root 2 value. So here these 2 points field is maximum and this point field is minimum. So this is the field d2 field, and this is the field versus distance graph. You apply from x equal to minus r by 2 to plus r by 2, the field is maximum. So at these points, the field is maximum field. So you can understand about the ring, how to calculate that. So now coming into arc. So in a previous slide, 2 more points I have to discuss here. That is, suppose x is equal to 0. So that means at the center. So field is also 0. There is no field. Then this is conducting sphere, charge resides on surface, conducting ring, sorry, charge resides on the surface, it will be outwards, radially outwards. So inside there is no charge. So at the center of the ring, the field is 0. So when compared to x is very, very small than r, x is very, very small, then we can neglect x square term. Neglect x square term. So x will be there, but x square term is neglected. Then the field where x is very, very less than r. So that is equal to, you get kqx by r cube. Means x is neglected, so you will get kq by r cube. So like that, given x value comparably equal to r something, so then you can substitute and you can find out. This is the final equation of field due to ring. Maximum is at x equal to plus or minus r by root 2. So you substitute plus or minus r by root 2, you will get maximum field in the place of x. So now this, that value you can find out by substituting x value. Now from the arc, first of all, that is, so consider any arc of length L, length of the arc is equal to L. So then L is equal to R phi. Phi is the angle of arc at its center. So this is the center of arc, consider. This is the center of arc. So to find out this, any means due to this arc, I want to find out means any small element you consider first of all. Small element. So anywhere on the length of the arc, small element, that is, so dl. This one how lambda into means dl is equal to r into d theta. So this dl element is making angle d theta with the center. Theta with center. So now this total arc angle is phi. Consider a symmetric line, which is bisecting the center and the length of the arc. So here this is theta. Now theta is varying. The theta is, the limit for theta is equal to minus phi by 2 to plus phi by 2 I can apply. If you take theta here, 0 to pi you cannot apply. If you take theta here, so that will be 0 to pi by 2, means pi. If the theta here I have taken, therefore this side is minus pi by 2, one side is pi by 2. So these are the limits for theta. So now you know dq is equal to lambda into dl, because it's the arc. So dl will come, linear charge density. If it is the disk or 2-dimensional body, lamina, 2-dimensional lamina, then sigma into di will go. Then dq in that cases means in the 2-dimensional body, in case of 2-dimensional body, this is sigma into dA or ds. For 3-dimensional shape, means solid sphere, hollow sphere, like that. So that is rho into dV. So this is surfacial charge density or areal charge density, and this is volume charge density. So like in center of mass and rotative motion, to find out the center of mass position for different distribution of mass, we use the dm for linear bodies, for spherical bodies, and for 2-dimensional body, 2D, 3D, and 1D. So similarly here charge also. So now at this point, field to this small element, so will be, so this is the bisecting line, this is the bisecting line, don't confuse. So this is the dl element. So dq charged point, and here one at the center there is a one unit positive charge is there, unit positive charge, one coulomb. So the along the line joining, this is the radius r, this is the radius r, and everywhere this all the lengths are radius r only. This is r2. So here this is theta, means here also theta. So this is the direction. So similarly about this bisecting line, consider another dq element here or dl element in the symmetric angle. So then here also same again, de means in this direction there will be d to this, there will be de like this, symmetric field. So now two components be cancelled and cos theta component only integrated to get total charge due to arc. For here field is equal to, so here I can take here lambda that equal to dq. dq is equal to here lambda means q by phi I can substitute. Means the total charge of this length arc is equal to q by phi into dl is means q by means this is L means q by L. L is equal to r into phi. So here L is equal to r phi, length of the arc. Therefore q by L, lambda is equal to q by L, linear charge density. dl is equal to here dl is equal to r into d theta. So then r get cancelled. Therefore dq is equal to q by phi. Phi is the total angle of arc and the d theta is the element of angle between angle of dq. So now we know electric field E is equal to E d to the small element E is equal to k into dq by the distance r square, right? So k into r square. So this is dE. I want E means total electric field due to length of the arc, that equal to integral dE cos theta. So that is equal to integral substitute dE value k dq by r square into cos theta. So that equal to k dq means q by pi r square integral cos theta d theta. So here that is one is minus pi by 2 and the limit is pi by 2. So now after integrating cos theta we will get sin theta. So that is equal to kq by pi r square into sin of pi by 2 minus of sin pi by 2 minus of sin minus sin, therefore minus into minus plus sin pi by 2. So that equal to 2 kq sin pi by 2 by pi into r square. So this is the required answer for. So here k value you can substitute 1 by 4 pi epsilon naught r square into phi. This is the electric field due to arc. So max means this phi value you can substitute. Phi, the given phi value, pi by 4, pi by 2 or 2 pi you substituting also you will get same answer. Okay. So 2 pi d2 at the center, 2 pi means total ring at the center 0. So here sin pi will be 0, total 0 will come. So for pi by 2, so then you can substitute. Here pi by 2 means pi by 4, 1 by root 2 will come, and here pi by 2 will come. So phi value and here phi value, substitute pi by 2, pi by 4, depends on 60. Phi means here the angle of arc. Phi is the angle of total, phi is angle of arc, that can be 30, 60, whatever you can give. So you substitute, you will get answer. So this is due to arc. The ring and the arc is completed. So we got it. So now going to disc. So disc is two-dimensional lamina. So consider a disc like this. So this is the disc of radius r. From the disc, so in the distance x, there is a one point P is there. So at this point P, one unit charge is placed. So I need to find out the field at this point in the distance x from center of the disc. So disc is, the combination of ring. So consider a ring in the distance y. So one surface with the distance y, consider ring, or small r you can take, a small r or y. So small ring with width dy. So this is dy. The ring thickness is dy. So now this outer surface, in this small, the ring like structure, thickness with dy. So all these rings are connected up to 0 to r, means y is varying from 0 to, the y limits is, here limits of y is equal to 0 to r. So based on this, we have to use integration here. So now this is the small element of ring I consider. So this charge is equal to dq, that equals sigma into dA. Sigma is surfacial charge density. So here dA is equal to, if you take small r or small y I have taken here, that you can substitute y plus dy. So then dA is equal to 2 pi r dr will get. So r you go with r here, r and dy. Otherwise y means, according to my diagram, that is equal to 2 pi y dy. So whatever you can substitute, concept. So now dq is equal to, how much will come now? dq is equal to sigma means total charge of this disc by the area, means charge for unit area. The surface density means what? Surface charge density means charge for unit area, that equal to pi r square into 2 pi by dy. So now field at this point due to this again small this element, the thickness dy thickness. So it will be, so line is same process will go, that equal to dE I will consider there. So dE I will integrate. So we know due to this ring, the E is equal to, means dE is equal to, means U is equal to, if it is element, this charge of disk is equal to dq, therefore the dE is equal to how much will come? So already ring we proved that equal to dq into x, k into dq into x by root over x square plus y square 3 by 2. It is the ring, right? For ring we will write now. Same process will follow in the first step like that. That equal to here y square plus this x square whole power 3 by 2. Whole power 3 by 2. So now substitute dq value here, and then we can integrate. So integral dE, here cos theta no need already. So here y is integrating from 0 to r, so no need of theta. dq is equal, k equal to, means dE integral dE is equal to k into q by q into 2 pi y dy into x by y square plus x square whole power 3 by integral. So now I am going to integrating y into dy. For consider here y square plus x square as something t r z, x square plus y square consider as z. So that is equal to, so then, so I want to y dy. Therefore y dy means, so 2 y dy is equal to, I will get answer dz. So now we can substitute here, that is equal to k q 2 pi x. So integral, these are all constant with respect to this consideration. Therefore here you will get, in the 2 is not there, here 2 y dy is there. Now 2 y dy I will write as dx by y square, means z whole power 3 by 2. So now you can see, so y is varying from 0 to r. Therefore y is equal to 0, the z limits are, z is equal to, y is equal to 0, z is equal to x square. So now y is equal to r, z is equal to x square plus r square. The limits of z is equal to here 0 to r, y limits. Then I have taken this is as z. Therefore limits are changing into x square to x square plus r square limits. So now z power minus 3 by 2. So minus 3 by 2 plus 1 by. So you know integral x power n is equal, n dx is equal to x to the power of n plus 1 by n plus 1. So here n is equal to, it will go up means minus 3 by 2 will come. Therefore k q pi x integral means integral x square to x square plus r square z power minus 3 by 2 into dz. So this is integrated, will get minus 3 by 2 plus 1 is minus 1 by 2, means z root over z down will come, and the denominator minus 1 by 2 is there, 2 will go up again. So that equal to minus 2k q into pi x integral, means integration already completed, that equal to 1 by root z from where to where, x square to x square plus r square. So after substituting these values here, so 1 by x, this x also bring inside, that is equal to minus 2kq pi, 2kq pi. So here dq is equal, I substituted pi r square mystery here. So if you see this pi r square is mystery here pi r square is there. So here also pi r square is there. So pi get cancelled. So here also pi r square is there. Pi get cancelled. Here this pi will not come. Only r square is there down. So here also pi is not come. Only r square is there. That pi r square miss. So now, if you take now, otherwise if you want to keep pi, here pi and here also pi keeping means this you can write sigma. You can write sigma also here. So that is your wish. Now here 1 by root x square means x I can write. X square root over x square means x minus 1 by root over x square plus r square. So now after simplifying, you will get this equation. So x also take common. So here pi and pi keep like this. So q by pi r square I can write as sigma. Q by pi r square is equal to sigma value. Q by pi r square I can write. So sigma by. So here k value 1 by 4 pi epsilon naught. 1 by 4 pi epsilon naught. Then here 1 pi is there. Here 1 pi is there. So see, I will write here in this box. I will write. Try to understand. So finally, the answer is like this. So otherwise here I will write C. So you are getting E is equal to 2 k means 1 by 4 pi epsilon naught into here sigma q by pi r square I am writing as sigma into pi is there here extra and x also there 1 by x minus 1 by root over x square plus r square. This is the final answer. So now these two get cancelled. 2 and 4 get cancelled. Pi get cancelled. That is equal to answer is sigma by 2 epsilon naught. X go inside, x by x 1 minus x by root over x square plus r square, x square by r square whole square by r square. This is the answer for this. sigma by 2 epsilon naught 1 minus x by root over x square plus r square. So if continue this, so here the disk is infinite charge, means the disk is infinitely long, more. So here we will apply some cases here. So disk is infinitely long, that means x is very less than r, that means x leads to 0. So infinitely charged sheet is infinitely long, so like this charge sheet. So this is non-conducting sheet, consider. So infinitely charged land, so like that here everywhere charge is there. So now what happened, this sheet, so this x compared to this infinite length of charge, r tends to infinity, the radius tends to infinity, that x back becomes to 0, x leads to 0. So then for infinite sheet, infinite non-conducting sheet, infinite non-conducting disk or sheet, disk become like a sheet now. So E is equal to sigma by 2 epsilon. This point is very important, remember. So E is sigma by 2 epsilon for long sheet of charged body, charged sheet, long uniformly charged sheet, for E is equal to sigma by 2 epsilon naught. So this is can called as conducting, non-conducting sheet also. Conducting sheet, non-conducting sheet difference means conducting means charge resides on surface only, non-conducting means charge is distributed. So for example, it is like this. So this is a sphere, consider. So it is called as conducting sphere, means charge is resides on surface of the body only, inside charge is 0, or you can call it as a cell also. So if the solid sphere charge is inside, distributed uniformly everywhere, so then it is said to be non-conducting sphere. So this is the main difference between conducting and non-conducting sphere, you can understand. So now see, if for this is now this long sheet will become as non-conducting sheet, for non-conducting infinite length sigma by 2 epsilon naught, for finite length sigma by 2 epsilon naught into 1 minus x by root over x square plus r square. So here one more point you have to remember, this formula, the field of a infinite long sheet is independent on the radius and means dimensions, independence on dimensions, means from where which point you have to find out, or at every point from the center or from the sheet, infinite sheet. So sheet means thickness will become very less compared to the radius or long of the sheet. So then it is independent on remaining dimensions. It depends on the surface density and medium. So these two values it depends. So I hope you understand here this point. Sigma by 2 epsilon naught for long sheet, it is independent on dimensions. So coming into next, due to conducting hollow sphere. Conducting hollow sphere, or I can go non-conducting solid sphere, both are same only. Non-conducting solid sphere. So that means charge resides on surface. So this is actually can explain by using, simply by using Gauss law. Gauss law next I will explain. So here, if you consider this total charge as a point charge, so then E is equal to K into Q by the radius square, r square. So that means 1 by 4 pi epsilon naught Q by r square. This is the field for conducting hollow sphere. So if any other the point means on the surface, it is the field formula on the surface. So point consider, so anywhere one point is considered. At this point I want to find out the field, so which is in the distance from the center, in the distance small r. So this is the point A, consider. This is point B, this is point C. So the point A, the distance small r is greater than capital R, means more than radius. For point B, it is on the surface. So point C is less than R. So that means for point A, the field is equal to, point A means outside the sphere, point A is equal to KQ by R square, small r square. For point B, EB is equal to K into Q by K into Q. Q is the charge of conducting cell or non-conducting sphere, for it is capital R square. If it is R is inside, so for R is less than R, EC is equal to 0. Because already explained one gun example, the field lines always act away perpendicularly from the surface, away, radially outwards. So inside there is no charge. Inside the sphere, in conducting cell, there is no non-conducting or conducting cell, there is no charge. Okay, that is the reason. That is the reason there is no field lines. So EC is equal to 0. So you got this one. So now if you take the graph for field and distance R for hollow sphere R, hollow sphere R, so this is non-conducting. So sorry, non-conducting solid sphere. So hollow sphere or non-conducting solid sphere. So now, so field is the E. So now from 0 center, at the center to R value, here it is R. So here field for hollow sphere. So this total is 0. So field is at R is equal to R point only, field start, remaining and all 0. So here field is 0. So this is for r up to r equal to r. So r less than r, field is 0. So here field start. This is k cube by r square. Here field start. So up to here 0, no field. So when r is greater than r, so it will be, and here if you see this equation represents the parabolic equation. So the field will be decreases and transmit to infinity. So this is field versus r graph for conducting solid, means conducting hollow sphere or non-conducting solid sphere. So this is graph versus E and R. So coming into next one. So this is only means all the points I explained for hollow sphere. Uniformly charged solid sphere. So uniformly charged sphere. So consider like this. So charge everywhere is there. Uniformly charge distributed. Charged non-conducting sphere. Uniformly distributed non-conducting sphere it is. So on the surface, one point, away from the surface, another point, and inside surface, another point. So C, B, A, similar. So for A point, so this charge conducting sphere behave like a point charge. So therefore, EA is equal to 1 by 4 pi epsilon naught q by small r square. So here r is greater than. For EB is equal to point on sphere, then kq by r square. For EC, to get the EC point, so charge is not 0. So you have to find out the, so effective charge is sphere, effective charge q dash you have to find out. So this is small r radius or x radius consider. So then, so 4 by 3 pi r cube sphere has charge q. So now 4 by 3 pi x cube sphere have charge q dash. So that means q dash is equal to q by 4 by 3 pi r cube into 4 by 3 pi x cube. So this already we have studied in gravitation. So effective mass. So if you understand this is, then you will get the charge q dash is equal to charge density into, means your density also volume into density is equal to q, charge density will go. So that equal to 4 means what will get q x cube by r cube. So this is the charge for r cube. This is the charge of this one. So therefore field is equal to EC is equal to, I can write. So EC is equal to k into q dash by x square, right? K into q dash by x square, that equal to k into q x cube by r cube into x square. So x square, x get cancelled, that equal to k cube by r cube into x. So this is very, very important. So now if you see field versus distance graph, so for uniformly charged solid sphere, so we can say it is non-conducting, uniformly charged distribution, non-conducting sphere. So inside it is proportional to x, right? The field is proportional to inside, from center to surface, field is linearly increasing, right? The linearly increasing with respect to x value. X value increases, this value also increases. Onto surface, x value become r get cancelled, r square. So it will be verified. So therefore, linearly increases up to x is equal to r. Means this is x value. So x is equal to r. The field is increases linearly. So here field is equal, at this point field is maximum, that is equal to k cube by r square. This is the maximum field. So thereafter again parabolic equation, it will be r square, means here E inversely proportional to 1 by r square. Here E inverse directly proportional to x r r. So it is linearly increases up to the surface for uniform solid sphere. Thereafter it will be reduced like this parabolically. So this is the field calculation. All the formulas you remember. So all the fields due to ring, disc, and arc, hollow sphere, solid sphere. So hollow sphere, solid sphere, semi hollow sphere and all I'll give by using the Gauss law again in another section. Thank you all. Thank you.